Assalamualaikum and hi everyone. Topic 10, Application of Differentiation, Lecture 3 of 3, Part 1 of 2. At the end of the lesson, students should be able to solve problems regarding rate of change, including related rates. Rate of change. 10.2, Rate of change. If y equals to fx, then dy dx is the rate of change of y with respect to t. When you are talking about rate of change, usually it will refer to the derivative with respect to time. Okay, the rate of change of quality q dq dt means the rate of change of q with respect to time t. The rate of increase is positive and the rate of decrease is negative. The rate of change of y and the rate of change of x can be shown below. Okay, so dy dt is equals to dy dx, and you have to multiply with dx dt. Okay, this is we apply chain rule here. Okay, strategies to solve related rate problems. Okay, number one, you need to draw a picture and name the variable and the constant. Usually we use t for time and assume all variables are differentiation function of t. Number two, you need to write down the numerical information in terms of the symbol you have chosen. Number three, write down what you are asked to find, usually a rate expressed as a derivative. Number four, write an equation that relate the variable. Okay. Number five, differentiate with respect to t to express the rate you want in terms of the rate and variable whose values you know. And number six, evaluate and do the calculation. Okay, now we continue example 5. Gas is escaping from a spherical balloon at the rate of 2 per minute. How fast is the surface area shrinking when the radius is 12 meter? Okay. Example 5. Gas is escaping from a spherical balloon at the rate of 2 meter cube per minute. How fast is the surface area shrinking when the radius is 12 meter? Okay, so the information given here is we have a sphere, a balloon. The gas is escaping at the rate of 2 meter cube per minute. Yeah, so 2 meter cube per minute. The unit here is cube. Yeah, so the gas is escaping. We know that this is dV dt. Escaping here means the balloon is shrinking. Okay, so you have to put negative because the volume is escaping from the gas is escaping from the balloon. So you need to know the formula for volume. Volume for a sphere, volume of sphere is given as V equals to 4 over 3 pi r cube. Then you need to find out what is dV dr. That is equals to 4 over 3 pi 3r squared. Then we can cancel out 3 and the answer is equals to 4 pi r squared. This is dV dr. Okay, now what is the surface area of the balloon. The surface area is given as S. The surface area. Okay, I will let as S. The surface area for the balloon is given as 4 pi r squared. Then what is dsdr? Is equals to 4 times 2, 8 pi r. Okay, therefore now we will use chain rule. Okay, dv dt can be written as dv dr multiplied with dr dt. Okay, this is the chain rule here. So dv dt is already given to you. dv dt is equals to negative 2. I will substitute here negative 2. dv dr, we already find the answer, that is 4 pi r squared. Okay, dr dt, we want to find here what is dr dt, and we solve to get dr dt is equals to negative 2. You need to divide by 4 pi r squared and simplify. You will get the question asks what is dr dt when r equals to 12 meter. Okay, so now we can substitute r here. That is negative 2 over 4 pi 12 squared. Okay, this is dr dt. Okay, now we continue. The question asks how fast is the surface area, which means the surface area I will let as S. Therefore, ds dt is the rate of change of surface area. Okay, so this is the question asked. So by using chain rule, we can write ds dt can be written as the rate of change of surface area can be written as ds dr multiplied with dr dt. Okay, because the surface area is relate on the radius, and the rate of change of radius is dr dt. So therefore we can substitute what is ds dr, that is 8 pi r. dr dt, we have already the answer, that is negative 2 over 4 pi 12 squared. Okay, now at when r equals to 12, you can substitute here, that is 8 pi times 12 multiplied with negative 2 over 4 pi 12 squared, and simplify. You will get pi will cancel out with pi, 12 you can cancel out with 12, and the answer is negative 1 over 3. Okay, this is ds dt. So to put it into words, thus the surface area is negative here, means is shrinking at the rate of 1/3 meter squared. Surface area, the unit is meter squared per minute. Okay, now we continue example 6. water is running out of a conical funnel at the rate of 1 centimeter cube per second. If the radius of the base of the funnel is 4 centimeter and the height is 8 centimeter, find the rate at which the water level is dropping when it is 2 centimeter from the top. So, to solve the question, firstly you need to draw the diagram for a cone. Secondly, you need to know what is the formula for the cone. The volume for a cone is given as 1/3 pi r squared h. Then you need to write down what is the information given. The water is running out of the cone at the rate of 1 centimeter cube per second, means you have to write dV dt, volume. The rate of change of volume is equals to -1. Negative because the water is running out, 1 centimeter cube per second. Then you have to write down what is the question asked here. The question asks, find the rate at which the water level is dropping. So the question asks, what is the rate of the water level dropping, means height, dH dt. Okay, so you have to write what's the question asked here. Okay, now we can start answering the question. Okay, now by using the similar triangle, if this is the level of the water at any time t, then we can use the ratio here by using the similar triangle. That is height h over 8 is equals to r over 4. Okay, therefore you can write what is r in terms of h. R equals to 4h over 8, or can be written as r equals to h over 2. This is the relation between r and h. Okay, so now we will use the formula for the cone. That is, volume for the cone is equals to 1/3 pi r squared h, where r is the radius of the cone and h is the height of the cone. What I want to do here is I will write the volume in terms of is either r or h. Now I will write volume in terms of h. Therefore, I need to substitute r here with h. Therefore, we will get 1/3 pi r squared, means h over 2 squared times h. Okay, simplify, you will get volume is equals to 1/12 pi h cube. Okay, then from here we want to find out what is dV dH. If V is equals to 1/12 pi h cube, dV dH is equals to pi over 12 multiply with 3h squared. Simplify, you will get dV dt is equals to 1/4 pi h squared. Okay, so now we continue to find what is the rate of change of volume. So dV dt. dV dt can be written as dV dH, because volume is varies with height. Multiply with DH dt. Okay. So now we want to find out what is DH dt. Therefore, we will substitute here. You are given the rate of change of volume dV dt as -1. So I will substitute dV dt with -1. dV dH is equals to 1/4 pi h squared. Multiply with dH dt. Therefore, we can simplify to get dH dt is equals to -1/1/4 pi h squared. Okay. The question asks what is the rate of water level when it is 2 centimeter from the top. So imagine this is the height of the cone, that is 8 centimeter. When the water level is 2 centimeter from the top, means this is 2 centimeter. So what is the water level at this time? So the water level is 8. H is equals to 8 minus 2, that is H equals to 6. Okay, so this is the water level, means 8 we have to minus 2. So we will substitute H equals to 6 into the formula here. Okay, therefore you will get -1/1/4 pi H. I will substitute with 6 squared. And simplify, you will get the answer is -1/9 pi. Okay, 9 pi here. So what is the conclusion that we can make here? So we can say that the water level is dropping at the rate of 1/9 pi centimeter per second. Okay, so the unit is centimeter per second. Okay, I write the unit here, -1/9 pi centimeter per second. Okay, that's all. Thank you.